Alright, this is lesson 7.2, multiplying and dividing rational expressions. In this lesson, what we're going to be doing is going a little bit further than what we did in the last lesson, that we won't just have one expression, we're going to have two of them, and we're going to either be multiplying or dividing them. Alright, so let's take a look at what we got here. The strategies for multiplying and dividing rational numbers can be used to multiply and divide rational expressions. And so why I say this is that you guys actually have quite a bit of experience doing this in going all the way back to grade even 9. All non-permissible values of each expression being multiplied or divided must be stated. So that's definitely becoming a theme here. I always want you to state your MPVs before you start a question here. Okay. What I notice that some people make the mistake of is they don't look for their NPVs until they've completely simplified an expression, and then what they'll do is they'll see that, oh, well, there aren't any because maybe the variable's canceled out. But you always have to look for your MPVs, at least I suggest, at the beginning of a question. So for this one right here, I notice that there's nothing with the 9 that you need to worry about. But with the 5a squared, right, if the a was equal to 0, then you would have a problem here. So I'll write my NPVs in blue like so. Now let's try and simplify this. What I would notice here is that there are a couple different things you can simplify. The a right here will simplify with one of the a's, basically getting rid of the squared. The 3 right here is going to simplify with this 9, leaving with the 3. Okay? And that looks to be everything that you can simplify. Now you have to be careful if you do that same method that I did there. Sometimes things can get a little bit lost in the translation, alright? So make sure that you are careful when you start canceling things out. Now I can multiply my numerator together. I have 2b squared all over 3 times 5 is 15, and I have one of the a's left. Right here, check, is there anything else that you can simplify? And in this case, there is not. Alright, let's go on to b right here. B, what do I see? Well, we first got to deal with your MPVs, so I will state them. Noticing the 3x right here, I would have x cannot equal 0. The 8x right there, that would also be an x cannot equal 0. And then if you check the x plus 2, well, what number, when you put it into that bracket, would make that 0? You may be able to just look at it and recognize, but the easy way is what you can do is just take whatever that bracket is. Take the x plus 2 and set it not equal to 0, and then just solve. That tells you that x cannot equal negative 2. So these two would be your MPVs for that question. Okay. Now let's take a look at trying to simplify this. Well, what do I notice? I notice that the x plus 2's are going to go away from me. Okay. I notice that I have an x squared in the numerator, and I have 2 x's down here. Therefore, giving you an x squared, those would cancel. I notice that this 2 and the 8, they're both divisible by 2, leaving you essentially with a 1 and a 4, like so. And that seems to be it. All right. So in my numerator now, I have 5. X minus 4, and the denominator I have 12. Very straightforward, alright? Probably giving you more real estate than you needed on that first page. Let's go down to C and D here. Alright, so again, this might be a good spot for you to try doing some of these on your own. We are going to be dealing with division here, so you may want to watch one of them. It's your call. So what I'm going to do here is I'm going to first go and kiss and flip. Alright, I want to get rid of my division sign here. And so what we do, the kiss and flip's a little thing I use to memorize what to do. So the kiss represents, you change this to a multiplication sign. Normally we use an x, so that's where the multiplication comes in. And then the second expression here is just going to flip, so we have this. Okay. Now you actually, for these division ones, you have to check both of these highlighted regions. Okay. Basically for anything in the numerator or the denominator that could make those 0. Because since we're taking an expression and dividing it by another expression, either the numerator or the denominator, those could both give you 0. Okay, so you have to be wary of that. For this one, what you need to just key in on is the 7n squared. What I notice with the 7n squared, well, I notice that if you made n not equal to 0, then you'd have a problem like this. Okay. So now that we have this question ready to go, let's go and try and simplify this. Well, got to be a little bit careful here. Okay, what I'm worried about that some people may do here is they may try and just cancel out the 7n cubed and the 7n squared there. Notice that because of those brackets, that's a little bit different, right? So when I simplify here, what I'm going to do, there's many ways to go about this, but I'm going to go and I'm going to see, okay, the 12 and the 4, those are both divisible by 4. That leaves me with a 1 and a 3 right here. Now, my choice is what I'm going to do is I'm going to multiply all the numerators together. This gives me 21 n to the power of 3, all divided by that 7n, all squared. And what I'm going to choose to do is I'm going to go and take that 7n squared and square everything. That gives me 49n squared. Now you'll notice that, yeah, you can simplify the n's. The n's are just going to leave you with an n in the numerator. Okay, and then we need to look at a number. Oops, I actually neglected my negative. Should put a negative in there, negative in there. What you should notice now is that the negative 21 and the 49, those do have a number that goes into both those. It turns out that, what do we have? We have 7 goes into both those, leaving you with a negative 3 and a 7. Okay, so this would be written in simplest form. My NPV was that n could not equal 0. Okay, let's check this next one. So this next one right here, what I would do first is I always like to go and get your kiss and flip on, invert and multiply, some people call it. So we do this. We are now multiplying by 3x onto x plus 5 and 10 onto x minus 3. Okay, and in blue again, we'll look for your NPVs. Your NPVs, x cannot equal 0. I'm getting that from this one right here. And we also have x cannot equal, that would end up being a 3 right there. And then the last one is, you actually could not have x cannot equal negative 5 there. Because if you imagine, if you had a negative 5 right in that stage, right, that would end up making this part 0. Whether it's in the numerator or denominator doesn't matter, because since we're taking this expression and dividing it by the other one, you'd be dividing by 0 essentially, and we can't do that. So we're ready to go now. Let's try and simplify this. I notice that I have an x minus 3, an x minus 3, I have an x, I have an x, I have a 5, leaves you with a 1, this will leave you with a 2, and for me I believe that that is all simplified. Now we have a 3 in the numerator, an x plus 5, and the denominator we simply have a 4 as your final solution for that. Okay, let's go on to the back page, let's look at a couple tougher ones, and then you guys will be good to go here. When a polynomial in the numerator or denominator is a binomial or polynomial, it may be factored before simplifying the expression. So here we're going to look at what happens when we go ahead and do that. One of my suggestions when you deal with something like this is to go and factor everything first and then look for your NPVs. Alright, so what I'll do right here is I'm going to go and I'll attack this and see what I get. So factoring my numerator here, I have x and an x. I'm looking for numbers that multiply to give you 20 that have a sum of 9. That, of course, is 5 and 4. This next one down here, it's going to take me probably 2 steps. What I notice is that I have a 2 that I can take out of all 3 of these terms. So I'm going to have 2 brackets x squared plus 3x minus 4. Now on the other side, this is one that I find gives people some difficulty. Notice that that is actually a difference of squares. What you do is you take the square root of both the terms. Oops. You have an x and a 1, make one of them positive, make one of them negative. In the denominator over here, we can factor out a 3, leaving you with an x plus 5. Okay. Now, simplifying a little bit further, before I start canceling things out, I'm going to go and just make sure that the denominator right here is simplified completely. And when we factor this, we get x plus 4 and an x minus 1. And so now the nice part about this is it's easy to attack what your NPVs are. Okay. So what I will do is I'll look at my denominators first. For this one I see that x, maybe I'll do it in blue here, x cannot equal negative 4, x cannot equal, this one would be 1, and x cannot equal negative 5. Now, you do not need to worry about the numerator for this one because we're multiplying, right? And when you take an expression, you can technically go and multiply by 0. It's just you cannot take an expression and divide it by 0 like we've done before. So now I will try and simplify. Simplifying here, I will notice that these x plus 4s cancel. This x minus 1 will cancel over here. All right. And the x plus 5s, those cancel. Lots of stuff is canceling. We have x plus 1, all divided by now 6. That's simplified quite a bit. Okay, good to go. Last one. So this one, again, we have this division sign. So that means when you look for your NPVs, you're going to have to be careful about both the numerator and denominator here. I'm going to go and I'm going to do the kiss and flip right away. Okay. Actually, I can factor out a 3 while I'm doing this. Good. And so when I kiss and flip here, I'm going to actually, instead of using the x, I'll just use the dot. I get 3. I'm going to factor out a 3 there from the numerator. Now it's going to become the denominator. When you factor out 3, we're left with x squared minus 4x minus 21. And right here, I'm going to also factor out a 3. This leaves you with x squared minus 4. Now we're still not done factoring, so I'm going to continue doing this until I'm happy with this, and then I will attack what my NPVs are. So I like to set it up like this. Let's look at the numerator right here. Numbers that multiply to give you negative 21 that have a sum of negative 4. That would be a negative 7 and an x plus 3. And then this part, x squared minus 4, notice that has a difference of squares. That's an x minus 2 and an x plus 2. Now from here, if you'd like, you are completely factored, and you can go and get your NPVs. So on the left-hand side here, I have the x minus 7. That tells you that x cannot equal positive 7. Down here, I have x cannot equal positive 2, and x cannot equal a negative 2 for that one. And again, since we were dividing, you also have to look at the numerator right here. Right here, we end up seeing that x cannot equal 7. We've already dealt with that one, so you don't need to write it again. And lastly, x cannot equal negative 3. Okay. Now let's go ahead and let's try and simplify this. I have x minus 2 cancels with an x minus 2, x minus 7, x minus 7, a 3 and a 3, and that looks to be good to go. In the numerator, we simply have an x plus 3 left, all divided by 3 multiplied by x plus 2. Okay. Be careful right here. I sometimes call it cancel-itis. Students will get excited and they'll start trying to divide by x here, divide by x here. We can't do something like that. So at that stage, you know that you're good to go. Okay. So that concludes this lesson. To summarize, what I want you to make sure you do for these is always go and factor. Once you factor, then you can state what your NPVs are and then go ahead and continue your simplifying.